associated with a robot. You got physics, gravity, tension, voltage, horsepower, acceleration, etc., torque. These are all the rules that you use. But even though you know all those rules, what do? You start building prototypes, right? And why do you build a prototype? It's a model. You're trying to look at something, play around with it, see how it really works, see how it really interacts, start seeing some of the pieces to it, because just looking at the theory is just not enough. Well, if you stop and think about, okay, that's the robot, what you're doing with the robot, every year comes around and you're given a game. It has rules also. Maybe it's not the physics or tension or voltage or horsepower, but each game has its own set of rules. Those rules have interactions with the game field, with the resources that you have, with the time that you have, and then how do you start thinking about, well, how do I prototype a game, if you will, to think about how I would walk through this, to start seeing about the interaction. And so that's what I'm going to do today, and what I've tried to build is to give some thought as to what this looked like, how you go about doing it, and some of the uses that you would use for it. Everybody with me?
Yeah.
Cool. And feel free to jump in any time with a question. So, when you first look at a game, you say, well, what gets me the most points? How long does it take me to get those points? How much time do I have? Do I have enough resources, totes or bins? So you start asking these questions. But, I say these are the obvious questions because, what are you really trying to get to? Well, what's the most effective way to score points, or what are the critical parts of this way, whatever that is? What do I focus on and what do I ignore? What do I do here? So that's where a model comes in, because it starts giving you some structure or thought process as to what this looks like. So, I did a quick graph here because I think so we're talking about how do you score points. Some of you may have seen a graphic where they have all these things stacked up. I don't really like that because it makes it look like the bigger the stack, the more the point. Well, kind of. What this is really telling you about, so on this point here is you got the number of points you can score. Down along this axis from 1, I just went up to 6, was the number of totes that you could stack. So, and that's really the way to do it. You've got 3 flavors, if you will. The lowest one is, what if I just stack totes, period. The second one is, what if I stack totes with the bin on top? And then the last one, which looks very much like that one, is what if I stack the totes and put a litter in it? So, all this is really telling you is that the litter's worth 6 points because it's always just 6 points higher than that. But what you can see is the value of the bin on the top gives you more points. It's a steeper line. So every tote is worth so much more than if you're just doing totes without the bin. As a matter of fact, I drew this dotted line just to show you that if you were to get 6 totes in the scoring area, it's the same as 1 tote, a bin, and a litter. So you start thinking about, okay, well, why is that important? When you start thinking about, well, how should I think about this? How long does it get me to bin or a litter or 1 tote or to stack or to move? What's the relative value of these things? And that's where you start thinking about the model and, what are my levers? What are my trade-offs? Can anybody off the top of your head that doesn't, you would look at this and say, well, is it, should I just have 3 totes in 1 bin, 4 totes? Is there a trade-off somewhere? So these are questions to ask. The other thing that I would highlight here is important also is with totes, if you stack 6 totes without a bin on top and put it in the scoring area, or you take 6 totes and you just put them in the scoring area side by side, which is worth more? It's a trick question. If you're not going to put a bin on top, why bother stacking them? So stacking is only relevant if you have a bin. If you don't have a bin, why would you ever waste your time stacking? So these are, I'm going to throw a lot of stuff at you here. These are a lot of the relationships that you keep in mind as you start playing around with all this stuff. So, big piece is really the time. So what are you going to do if you want to start figuring out the time? Well, you break this down into discrete steps. Going back to prototyping, are these perfectly descriptive of everything? No. Are they reasonably descriptive of what you would expect, like a prototype, what the robot would look like or what you want it to do? Yeah, if you're close enough, it's good enough to model. So these are the the bins that are how I just broke it into the parts for the discussion today. They're fairly self-descriptive. Move is just generic. It's just you move the robot, you position it. You know, feeding a tote, how long does that take versus acquiring a tote or stacking a tote, acquiring a bin, stacking a bin, feed a litter, acquire a litter, insert a litter. You basically, for anything that you're doing, it's going to fall into one of those buckets and you can put a time to it. So now that we've got those, we know that our teleop time is 135 seconds. I'm not doing autonomous here. Didn't try and build in cooperation into this. It's a model, it's a prototype, much like that. Just one piece at a time. Don't get too complex or too fancy. And then you can see is, what did I said everyone took 1 second. How many people think that it actually takes all these activities, just all of them as 1 second? No, it's not realistic. But it's a plug value. It's a way to start. You can even actually learn things by having those kind of numbers in there, and we'll see that in a little bit. So a little bit like the graph is I said, okay, well then I need to think about, you know, what is it that we're doing? So you can either have unstacked totes, which there's nothing to really vary in there because, you know, how many in one stack? One, it's unstacked. So you really don't change anything on that. Stacked totes, okay, that could be 1 through 6 for this game. That's the gray areas here, blue or whatever color it is. Stacked totes plus a bin, well, you got 1 bin involved there. And you could have up to 6 there, so that's a variable you could play with. Stacked totes plus bin plus litter, so you got the 1 and 1 down there. But again, the only thing you're playing with, much like the other graph, is the number of totes. Generally 1 through 6. So this is still doing the setup. Now, behind the scenes, you don't see what's done here, but this is all done in just an Excel spreadsheet. Based upon those times, on the numbers that are here, and the math behind it, they can figure out, well, this is how many points it's worth. This is how many time in seconds it takes to perform the task. Now this is what I did. The cycles per game, based upon 2 seconds, 2 goes into 135, 67.5 times. So that means based upon those times that I can do this 67 times. Well, you can't do half a time, so it's 67 times 2 is 134. That's how many points you could score during the game if you were able to do everything 1 second at a time doing unstacked totes. Again, I think fairly straightforward. The last one I think is meaningful, so it just tells you how many points per second you're scoring. But since you're playing over the same time frame, you would, you know, the total number should get you that also, but I think it's an interesting thing to look at. So, same thing as you go through all the rest of those, same math. You do the score, you figure out how many cycles you can get in, how many points you can take a look at, and the points per second. So, and what's good about this, and even at the 1 second, you can start saying, well, do I think these numbers are right? Well, at this point, who cares? You're looking at a relative value. All of them, if I assume that all of these are equally right or equally wrong, then I can actually see that, you know, chances are, where am I going to be most productive? And really that final number is that, you know, what this is telling me off the get-go is that it looks like you're going to get, you know, theoretically the most points of actually getting, like, you know, a bin, you know, with the bin or a bin with the litter. You know, that's where you start seeing the trend up that way. Now, there are some things that one piece is missing here, and that's one of the reasons I say that. I know this is a 1 also, is that time is a resource, but the other resources are how many totes, bins, and litters I have. There's been a lot of talk of, well, you know, I can feed 30, there's 28 on the playing field, there's 12 on the shelf in the center, there's an additional 4 bins on the shelf in the center. So, okay, our resource is going to come into play. Now, everything's 1 second. We're living in a fantasy world because nothing ain't that fast. And even then, you can see that this is for a single robot, that this robot, in this perfect world, has used 12 totes. Oh, you know what? 12. Oh, you know what? So, yeah, it's used 12 totes, but it's also saying 12 bins. We know that's not right. There's not that many bins out there. But I don't think you're going to be doing one tote, one bin stack anyway. So you can look at these numbers down here to get a sense as to how much resources you're using. And you can do in Excel something that just says, hey, it's above a certain number, highlight it in red. So that's why you'll see these numbers will change. So what I set that up is that you get a warning above 30 because, and I just picked that, not arbitrarily, but 30 is the number of totes that you can feed into it. After 30, you have to start picking them up in the game field. There's 28 on the game field. Why not? Bins, you've got 3 that are yours to play with, and then there's 4 on the center shelf that you can fight for, so the max that you could possibly have are 7, but that's only if the other guy doesn't get them first. And then litters, there's a total of 10 that you have out there. Again, I don't think that's much of an issue though, because you've only got 7 bins, so. And I understand there's a thing about litter on the field. I'm not trying to model that piece also. This is just, we're prototyping kind of just one section of this game to start getting to think about it. Are there any questions on that?
So if I were to extrapolate the data that you just presented up in the top chart, going back, forget about the time frame. We could plug in 5 seconds to 10 seconds per acquisition if we want. When we find out what actually acquisition time is going to be. Of the 4 different ways of picking and stacking and non-stacking within the same time constraints, does it seem to you that if we were unable to put the litter in, that the 3rd acquisition with a bin and just stacking would be the best one for time? Or would it just be not even worry about putting a bin on and just doing the number 1 and just putting a single stack? So you see, you score there 134 points, 90 points, 132,
yep,
and 180. And the question would be, which one is the most efficient?
Yes. Yep.
Okay, for the time. And it looks like the most efficient for the time, if we could accomplish it, would be the 3 stack. In other words, you'd have a bin, a tote, and the litter. Okay.
Because I'm going to go to the live spreadsheet and we can actually do this real time.
Okay.
So we can start playing around with.
Is there a determinant that may not require us to acquire all 3 items?
Well, and that
would score more points.
So a lot of different things, and they're all good questions. I think you can play around with in the model, but what the model won't allow you to do per se is that if you look at some of the games in the past, and Mr. Walensky was just talking about it, but most people here remember the Frisbee game where you had the big one that stood at the feeder, you fed it in, and it shot from the feeder and scored the Frisbee. So if you were modeling this, I'd probably say, acquire the Frisbee, move, set up, shoot, return, acquire, set up, shoot, and you could put time in there and everything else like that. Well, what the model won't tell you is that, well, what if we skip 3 steps? So when you look at the model, what you can start thinking about, well, if I skip these 3 steps and I made these, this 1 second, I just called it 0, you can start modeling how big of an impact that has. How much does that give me? What's the benefit? And again, the important thing here, and I think I have it right there, and here you can, all models are wrong, some models are useful. Words to live by. Everything that you have someone that I don't care if they're talking about economics, I don't care if they're, regardless of your political leanings on climate change, all models by definition are wrong. So the model I'm showing you is wrong. The important part is it useful? Can it make you think about what it is that you should be doing, how the things interact, what it is that you should try on the field differently, what are those things that are most sensitivity? And that's really what this is. What does perfect look like? What can I do? How much time? What are my resources? All else equal, how do the options compare that I have? What are the changes have the biggest and smallest impact? Essentially the sensitivity. These are the things that you can do with playing around. So while we spend a lot of time on the machine, and it's important to do that, you should also be spending a fair amount of time on the game, because how you play the game, do you think it has an impact on how you build a robot? huge. You know, so should the robot be being built to get things from the feed or to pick them up from the field? Well, how do you make that decision? Well, what's my game strategy? You know, what am I going to be forced to do? So, oops. All right. So this is the actual spreadsheet. All these numbers should be the same. I'm going to do a quick demo, and then I'm going to let folks just kind of, if you will, give suggestions. So when you do a model, one of the things is you should always, you know, does it make sense? Does it match reality? Here's one of the things that I noticed right off the bat, okay? If I have unstacked totes of 1 and stacked totes of 1, well, if this is only one high, then these two numbers should give me identical results, right? Do they? No. Why? Because I built the model to bake in that if you're stacking it, there's activity associated with stacking. So it thinks you're doing something to stack when you've only got 1. So the model is not as smart as it absolutely could be. But what you can do is go in and say, you know what? If I go up to the top and I set this to 0, what does that do? It changes it. Okay. All right. I understand it's not perfect, but you know, okay, I understand why it's not perfect and what it's doing. So you will see things like that. Now, you know, does that make or break the entire model? No. But it does tell you that when you're looking at the results, you should be looking very big picture, and the results should make sense to you. You should be able to tie them back to what you're seeing, what you're doing, and say, yes, I understand why. Or I think the model's wrong. So, Brian, to your question, you would come in, and so let's take, you know, so we're seeing it just 1. But we also know that we had those lines that came up, and the slope of those lines were different. So there's different values the more totes that were involved. So here's 1. Let's go in and take these all to 6.
Oh, the first one on stacked totes, shouldn't that still be 1? On stacked totes.
Yeah, but you're going to have 6 totes that are unstacked, so you're still using 6 totes.
Okay.
Which is still going to be worth 12 points.
It looks like stacked totes plus a bin is better than.
Well, you know what? You could look at it different ways, but yeah, because it doesn't really change your points per second. It's the number of stoke. It's a little bit of an odd. You could do it either way. It's a good point, though. It's a good observation. I'll leave it at 6 for the moment, just to show that you're using 6 totes at this point. So, what do you guys think about that? Now,
do some mathematics. So if you've got, on the first one, 12 points, and it took you 12 cycles or seconds, whatever that ends up, let's say 12 seconds, and you determine that's points per second at 1, but if you multiply how many times you can repeat that, then
this goes back that this unstacked tote it's a stack of 1. It doesn't fit well in this, and that's why, you know, changing that. That's why these areas, you can change these. I think I think that should stay 1 for doing that, and the math will work.
Okay.
Back to his point.
Well, then, if you do the mathematics and a number of cycles available, regardless of whether it's 1 cycle per second or it takes you 5 seconds, it looks like to me it's really beneficial if we can get a litter and the tote and the bin stacked, because even though we'll be able to do less, it seems like, you know, when you do the mathematics, you're going to get the most revenue out of that, point-wise, no matter what you look at.
Well,
even if you factor in, it might take you, and what you've done in this spreadsheet, it's going to take you more time to do that. So what we have to determine is how much of those time scales, is one of those ones to acquire the bin, is that really
So,
twice as much as that?
So let's take a look. So let's just for illustration, you know what, we're gonna say that it's a pain in the neck to insert the letter. It's, we go to 5. Does that change our results dramatically?
Oh, yeah.
Okay? So you say, you know what, we don't think it's 5, we think it's just twice as much, so it's 1 second to 2 seconds.
I think stacking is gonna be another one that's gonna be really intense too. Once you get it up to 6, trying to move slow enough so the bin doesn't fall off.
So, yeah, so if we think stacking a bin or stacking a toad, or, you know, you change that to a 2, what do you get? With the litter is a 2.
I think the bin is gonna be one that's gonna be hard. Well, first, the bin is the green recycling stuff.
Yeah, so we're going to say, you know what, this is acquiring bin, getting that and dragging around, that's a 6.
Yeah. So once we figure that out, what we do, we can plug in these numbers and we can get a more realistic, okay, this is how we should be playing the game, or this is how we have to have our alliance members play the game so we can be successful. Does that make sense to everybody?
Yes.
You see how valuable this is once we get the robot built and start playing around with the playing field and determining what our capacities are? Or if you're designing a robot, to even say, do we want to even do certain things?
Because one of the things that I have heard, and I've focused on a little bit, is that, you know, I'll mix a couple things here together. You've got 30 bins that you can feed in. You've got 28 bins that you can go out and hunt and gather yourself. And we know that as you're stacking this, no matter what happens, that's a step in the process of stacking is acquiring that. And if you can take acquiring and it goes from, you know, acquiring a toad, and we'll make this more realistic and say it was, you know, oops, not 43. We'll call it, I don't know, 3 seconds. So you can take a look at the numbers there. You know, 0.88 points per second for the last column. And you're able to actually drop that to 0 because you're just feeding it straight into the stack. So you go from 0.88 to 1.4. Not quite double. You know, so where should your time be in terms of acquiring or stacking? And also, so this is perfect world. This is still a pretty perfect world. You're using 27 totes, one robot who's living in probably somewhat of a fairy tale land that they're being able to do this much that quickly. So how should you be designing the robot in terms of, should it be getting totes from the feed or finding them in the field? What's your priority? You know, how do these relate? So again, this isn't going to tell you that this is the magic answer. Frequently, and this is a good thing, the model will confirm to you what it is that you already know. That should happen 9 times out of 10. Where it comes into play, though, is there's usually 1 time out of 10 where you go, huh, that's not how I thought it would work. And that's the one that really is of value out of it. And then fundamentally, I think, by pulling together a model and thinking it through, it forces you to really think about the game in a way, in a structured way, that helps you be more productive in terms of what you do. So anyway, I'll open it up to other questions. Yeah.
I think another resource that will factor into the maximum points per game depending on what strategy you go to is how much space you actually have on the scoring platforms.
So it's 15 feet, and it's a great one because I almost put on this one. To that point, if that's all you're doing, that max should be 22. And I think that's theoretical. Each one of the scoring platforms is 15 feet 7 inches, which is just enough room for 11 toes. No space between them.
Which way would it be stacked? Or placed on?
Look,
Sideways.
sideways.
Minimum space.
Yeah. Minimum space. And honestly, I think that's probably a little bit unrealistic because if you got anything that's trying to drop them on there, it's got to have space on either side to get them there. But you know, it's a model, it's theory. So that should be 22. So that's a limit. And that's also, you know, why you should be looking at the resources and the limits that are here. That was a good question, John.
It's interesting, when you change the acquire time, the acquisition time down to 0, the single non-stack, just sitting the totes up on the platform seems to be the most efficient in the higher point storage, except for you're limiting your amount of totes that you can do. Now, what we find in our gameplays when we go to our first competitions, especially at the BCU regional, is not as competitive.
Yep.
And that type of gameplay would be very successful, where you're just looking at acquiring the totes straight from the feeder without stacking at all, just taking one, putting it over, turning right around and getting another one, and using all your 30-some up by the end of the game, and you'll have a really high score just doing that with 3 robots. Yet when we get into a more competitive arena, which would be Worlds, for instance,
Yep.
you're going to see almost all the totes on some of these games will be stacked and used.
You know, when you start playing around with some of the numbers and you start putting some reasonable, realistic numbers in here,
You doubt it?
I will be very, very impressed
Yeah.
that if they're able to feed all of those in, stack them all up, put them all up there, and pick up, put in position, and get tall enough to fit them in all, and then place them in all the space they have available in 135 seconds.
You know, 3 robots.
3 robots. That's 3 robots
It's
kicking
going to be
butt.
close. I will challenge you on that. I've seen gameplay that's just amazing at Worlds, and there will be robots there that can do amazing things.
Yep.
And autonomous, they're set everything in autonomous, and then they turn around right after that, and there's just starts hitting 6, 6, 6, 6, 6 with a thing on the top of the thing, and it just blow your mind. But that's not going to happen to us at BCU, and it's not likely to happen to us up in Maryland. So this may be a pretty good strategy if we have other team members, and this is all they can do, is just take the 30 totes and run with them, because, you know, let's say it's only 20-some we can get on there. If we can stack 2 or 3 so they can put more on there, then that would be a pretty high score. For BCU, anything over 40 points would probably be a high score the first couple matches.
So, anybody who has Excel and actually knows just a little bit about Excel, this isn't actually very complicated. I mean, everybody here is doing, a lot of you are doing programming and everything else like that, so this is pretty basic. So, one of the things that if there is somebody here who is interested to, can email this to not just one person, I can email it to a couple folks, and you can take a look at it and play with it, add things to it, play around with the numbers, take a look at it, improve it. I am absolutely willing to share. So
What we'd like to do is not next weekend, but the weekend after next, go ahead and set it up while we're doing our gameplay and start looking at times it takes, the actual physical times it takes for us to do these tasks, and plug in real numbers.
okay.
And let that help us determine how to play the game. Because by then we should have a running robot
Yep.
in 2.5 weeks.
All right. And in conclusion, yeah, that's all I have. So yeah, just let any of the mentors know. Hopefully, be happy to share.